A very good evening, everyone. So, today I'll start with the topic of magmatic reaction and resorption. That is a continuation of the chapter that includes the texture of igneous rock. So, with this, magmatic reaction and resorption. So, what is magmatic reaction? It occurs when early formed crystals they react with the surrounding melt as crystallization proceed. So क्या होता है कि जब ऑलरेडी फॉर्म क्रिस्टल होते हैं वो उनका जो सराउंडिंग मेल्ट जो कि अभी आ रहा है उनके साथ जब रिएक्ट करते हैं क्रिस्टलाइजेशन प्रोसीड करती है सो दैट इज़ अ डेफिनेशन. नाउ वी हैव दी ओलिविन टू पायरोक्सिन रिएक्शन. सो एक रिएक्शन है ओलिविन टू पायरोक्सिन जो कि सिलिका मैग्नीशियम सिस्टम में हमें मिलती है. एंड यहाँ पे ओलिविन जो है वो मेल्ट के साथ रिएक्ट करता है जिसकी वजह से वो ऑर्थोपायरेक्सिन बनाता है जहाँ पे ओलिविन मेल्ट का इंटरफेस होता है. देयर इज़ अ फिगर इन द बुक एज वेल. नाउ प्रेशर ड्रॉप रिएक्शन. So this occurs when magma rapidly approaches the surface. Hydrous, phenocryst, hornblende, biotite, they dehydrate and oxidize, forming the rims of fine oxides and pyroxene. Magma mixing reaction, it's a compositional change from mixing different magmas can trigger, reactions. Now resorption. So refers to the refusion or dissolution of a mineral back into the melter solution from which it was originally crystallized. So resorption is like refusion, dissolution of a mineral. It just again become back to the melt or solution from which it was, basically a reverse reaction. And resorbed crystal often exhibit rounded corners and embayed textures. Sieve textures, there's a figure also available. So previously attributed to advanced resorption but may also result from rapid enveloping melt due to undercooling. So sieve texture is, the definition I've already explained. Now we have the irregular embayments. It's linked to the similar process of resorption or growth under disequilibrium conditions. So we have the sieve textures, we have the irregular embayments, and that comes under the resorption. So question might come again from this, like whether it's sieve or irregular embayment. Now we have the differential movement of crystal and melt. Middle alignment and flow texture. So trachytic textures, the definition, alignment of elongated or tabular microlites, commonly plagioclase due to flow. It occurs when microlites flow around the phenocryst. Now we have pilotaxitic or felty texture. It's the random orientation of microlites without alignment. Now we have the flow banding, that is description, is alternating layers of different composition that has been formed by mingling of two magmas as in chambers or as flows and flow near magma chamber walls. So middle alignment and flow textures, we have the trachytic textures, we have the pilotaxitic textures, and we have the flow bending. Now we have the sinuses. The definition, process where suspended phenocryst cluster adhere to each other due to surface tension. Now outcome. It may lead to the formation of growth twins due to energetic favorable orientations, produces multiple grain cluster that is known as cumulophoric textures. Now we have the specialized clusters. We have the cumulophoric textures, we have the glomerophosphoretic textures. So cumulophoric is adhering phenocryst clusters typically involving a variety of minerals. Now we have glomerophosphoretic texture. It's a special type of cumulophoric texture only, where clusters are composed of only a single mineral. So if I come to the conclusion from all this, so this is something, आप जेनरिक जो आपके टेक्सचर्स बताए जाते हैं उनसे थोड़ा सा अलग टॉपिक है, बट ये जेडी विंटर में दिया हुआ है. सो मैंने आपको बताया, पीछे से शुरू करते हैं. साइनसिस होता है एक ऐसा प्रोसेस जहाँ पे सस्पेंडेड फेनोक्रिस्ट क्लस्टर्स होते हैं अडेयर टू ईच अदर ड्यू टू सरफेस टेंशन, एंड जिसकी वजह से ग्रोथ ट्विन्स बनते हैं, और ये वहीं बनते हैं जहाँ पे एनर्जेटिकली फेवरेबल ओरिएंटेशंस होती हैं. ठीक है. और फिर मल्टीपल ग्रेन क्लस्टर्स बनते हैं जिनको क्यूमुलोफायरिक टेक्सचर कहते हैं. क्यूमुलो मीन्स मल्टीपल, फायरिक अभी ऑलरेडी नो. So, एक adhering phenocryst cluster typically involving a variety of minerals. Now we have the glomerophosphoretic texture. It is where the clusters are composed of only a single mineral. Now we have the trachytic, pilotaxitic, that is felty textures, and we have the flow banding. So trachytic texture, I've told you what exactly it is, and felty textures, random orientation of microlites without any alignment. And we have the flow banding. It's formed because of the mingling of the two magmas, and it flows near them, and the flow near the magma chamber walls. It's where this type of textures are found. Resorption is the reverse kind of thing. Sieve textures and irregular embayment is example of it. So that's all. Now texture of igneous rock. Okay, cumulophyric texture. It's found in andesite, example in Mount Logrin origin. And we have features. It has the sieve textures in plagioclase phenocryst, resorbed and embayed olivine phenocryst and hornblende phenocryst dehydrated to form iron oxides and pyroxene during eruptions. Significance: it indicates the disequilibrium during crystallization and magma mixing. So andesite, dacite, they both are the volcanic thing, and it comes under the cumulophyritic texture. And the significance is it's the type of texture that indicates disequilibrium during crystallization and magma mixing. Now we have the trachytic texture. It's found in trachyte. So example, Germany and um and basaltic andesite. Types: trachytic and felty texture or pilotexitic texture. Trachytic is the alignment of plagioclase microphenocryst due to flow, and felty texture or pilotexitic is the random orientation of microphenocryst. Now, significance: they reveals the flow moment of the magma before the solidification. So that's what trachytic textures does. Now we have the cumulates and their textures. So cumulates form due to the accumulation of early form crystals in a magma chamber. So we have the types of cumulate texture. Orthocumulate. It's the interstitial liquid crystallizes into minerals around existing crystal. Minimal interaction with the main magma. Now we have the accumulate. Crystal grow extensively, filling interstitial spaces. Almost no interstitial liquid remains. Now we have the heteroaccumulate poikilotic textures. The large interstitial crystals grow and encase the earlier mineral, and they form due to the exchange of interstitial liquid with magma. Now mesocumulate, it's the intermediate between the orthocumulate and accumulate. So what you have to take the key points out of it is orthocumulate में क्या होता है कि एक interstitial liquid जो है it crystallizes into minerals around the existing crystal. Now there's a minimal interaction with the main magma. Accumulate, it crystal grows extensively and they fills the interstitial space. Almost no interstitial liquid is there. Heteroaccumulate poikilotic, ये तो हमें पता है कि large interstitial crystals जो है वो earlier minerals को encase up कर देते हैं, and it forms due to the exchange of interstitial liquids with magma. Now mesocumulate is the intermediate between the orthocumulate and the accumulate. Okay, now we have the flow banding. So it's found in andesite, that is Mount Rainier, Washington. Description: it's the alternate layering of the different composition or texture caused by the flow movement during lava solidification. Now we have the primary twinning. So intergrowth of two or more orientation of same mineral due to crystallographic relationship. Examples common in feldspar, that is Caspar twins. Now we have the formation. It results from the nucleation error during the rapid cooling, and twin formation may also occur during the slower process like cyanosis, alignment of the floating crystals. I've already told you. What was this? Yeah, cyanosis is the alignment of the floating crystals. Now we have the volcanic textures. We have the microlithic texture. So it's a fine needle-like crystal in a ground mass that's called the microlites. Formation is results from the rapid cooling during the lava solidification. Now we have the ophitic textures. So plagioclase slabs are enclosed within the pyroxene crystals. That formation represents the slower cooling in basaltic lava. So plagioclase slabs are something that has been enclosed by the pyroxene crystals. Now we have what? Now we have intergranular. It's the subequal size plagioclase and pyroxene grains with interstitial glass. So interstitial spaces are filled up, and the pyroxene around the plagioclase. Now we have the hollow aligned texture. It's texture that is dominated by glass. It almost has more than 80% of glass. Obsidian, techylite is an example of it, and formation is extremely rapid cooling of silica-rich lavas. Now we have the vesicular texture. As the name suggests, it has the gas bubbles trapped in cooling lava create vesicles. Pumice is frothy, light, silica-rich with abundant vesicles, and scoria is dense, dark, basaltic with fewer vesicles. So sometimes the question might ask what is the difference between pumice and scoria. So that is the difference. Now we have pyroclastic texture. So pyroclastic rocks, they have been formed by the explosive volcanic eruptions, and it composed of fragmented material like tephra. Components are ash, pumice, rock fragments, and glass shards. And we have the features: pelletiers and hairs. Pelletiers and hair, glass fragments formed by the stretching magma due to explosions. And we have accretionary lapilli. It's a spherical deposit that has been formed by the condensation of ash and vapor. Okay, so Now we have the last topic, that is secondary textures and post-magmatic changes. And considered as a metamorphic in nature. Secondary texture are, that's something that has been formed after the original formation. It's a secondary thing, so that's why. So I'll cover this in next part. That will be more convenient. And with that, revise the notes and prepare your own notes and read the book and go through the pictures and everything. So thank you.